we are going to discuss about what is a streamline, what is a stream tube, what is path line, and what is a streak line. Right, what is streamline? Streamline is an imaginary curve. Streamline is an imaginary curve drawn through the flowing fluid in such a way that the tangent of imaginary curve gives the direction of the velocity. Right, suppose this is one imaginary curve. This is one imaginary curve. So here we are going to take one tangent like this. This tangent gives the direction of velocity at this point. That is known as streamline. Right. Now here we are going to take point P over the imaginary curve. Point P over the imaginary curve. Point P, that is xy. X is in the x direction. This is in y direction. X direction velocity is small v. Y direction, x direction velocity is small u. Y direction velocity is small v. Right? This is tangent at a point over the streamline. Over the streamline. Theta is the angle between the velocity v and the horizontal line. Now, tan theta equal to opposite side. This is opposite side, that is velocity v divided by adjacent side velocity small u. And this is equal to, this is also known as dy, this is also known as dx. Right? Tan theta equal to v by u or dy by dx. dy by dx. Right. This is the tan theta is equal to v by u is equal to dy by dx. V by small u is equal to tan theta or dy by dx. That is derived here. Now, tan theta equal to du by dx, that is equal to dy by dv. Right. So, this is the equation. From this equation, cross multiplication, that is equal to dx into v is equal to dy into u. This is one more relation. And also dx by u equal to dy by v. This is one more relation. This is also known as a differential equation in case of two-dimensional flow. Right? Differential equation for streamline in xy direction equal to dx by u is equal to dy by v. Whereas in case of three-dimensional flow, differential equation for streamline is equal to dx by u equal to dy by v equal to dz by w. This is about streamline. Right? Stream tube. What is stream tube? Stream tube is a tube that is imagined to be formed by a group of streamlines. Imagined to be formed by a group of streamlines passing through a small closed curve, which may or may not be circular. This is the diagram. Right? Stream tube means that is the combination of streamlines like this, combination of streamlines and closed in a small area. Right? One more point, a stream tube is bounded on all sides by the streamlines. That means stream tube means that is bounded all around by streamlines, so that there is no component of velocity. There is no component of velocity across the streamlines or normal to the streamlines. normal to the streamlines or across the streamlines, there is no velocity component because the stream tube is bounded by all sides streamlines, right? And another one, the variations of velocity in the streamlines are neglected. The variations of velocity in this stream tube, the variations of velocity in this stream tube is neglected because that is a very closed area. Therefore, this stream tube is also termed as stream filament. Stream tube is also termed as stream filament, right? This is about stream tube. Right, next one, this is the path line. Path line, right? Path line may be defined as the line traced by a single particle fluid, traced by a single fluid particle as move over a period of time, right? Path line means traced by a single particle. For example, this is one particle. After 1 second, that is different direction. After 1 second, having different direction, and after 1 second, having different direction. That means traced by a single fluid particle moving over the long time. Okay, that is the path line. And also, path line shows the direction of the same fluid particle at successive time intervals. Path line shows the direction of the fluid particle at successive time intervals. Suppose this is one fluid particle moving like this. This is only one particle with respect to time. After 1 minute, this is like this. After 1 minute, like this, like this, like this, like this. Only one particle, but because of the time, that is our successive time, this will shows the direction of the fluid particle, single fluid particle over the time or successive time intervals. This is about the path line. Right, this is the diagram. All of you, please see the diagram here. One single particle started here. This is the single particle moving like this. So that is, we have notated numbers 0.1, 0.2, 0.3, 4, 5, 6, 7, 8, 9, 10, like that. Same fluid particle after 1 minute, different direction. After 1 minute, different direction. So that after 1 minute, the successive time interval, this is the same fluid particle, this is the 1, 2, this is the same fluid particle direction. After 1 minute, the time interval is equal to 1 minute. Say we are going to take the time interval is equal to 1 minute. So this is the same fluid particle, this is the direction. Like that, 10 time intervals we have taken. This is the last fluid particle, this is the fluid particle direction. But already I told you, traced by a single fluid particle moving over a time period or shows the direction of same fluid particle at successive time intervals. Only one fluid particle, this is one time. After 1 minute time interval, this is one. These lines are path line. These are the fluid particle moving over the time, or the path line shows the direction of the single fluid particle at successive time intervals. Right? This is known as path line. Right? Next one point here. Two more points we are going to discuss about the path line. A fluid particle always moving tangent to the streamline, so that in case of steady flow, there is no change in direction of velocity. Therefore, if the flow is steady, the path line and the streamline both are coincides. Some cases, if the flow is unsteady, the path line and streamlines are different. Right? This is about path line. Another one, streak line. Streak line means is the line traced by the fixed points. Suppose Right. So this is one path line, this is another path line, this is one more path line. These are the different path lines, single fluid particle. But streak line means at a fixed point. Suppose this is point 2, right? The streak line should be joined or traced. This is a streak line. This is a streak line, and this is a streak line. So fixed points, point 2, point 2, point 3, point 3, point 3, and point 4, point 4, point 4. That means streak line means is the line joined the fixed points, that is known as streak line. Right? These are the streak lines. These are the path lines. These are the streak lines. Now here, this is point 7, point 7, point 7, point 7, point 7, point 7. These are the fixed points. All are number 7. So this is known as streak line. Right? Right. Streak line definition. Streak line may be defined as the line that is traced by a fluid particle, passing through a fixed point, right? This is same lines, these are the fixed lines, and also these are 9, 9, 9, 9, these are the fixed lines passing through a fixed point, that is known as streak line.